Let f of x equal 1 over the square root of x. Find the slope of the tangent line to the graph of f of x at the point 16, 1/4. As with all of the problems of this type, the slope of the tangent line to a function f of x at x equals 16 is the derivative of f at x equals 16. Using the definition of the derivative, this is given by the limit as h approaches 0 of f of 16 plus h minus f of 16 all over h. For this particular example, f of 16 plus h is equal to 1 over the square root of 16 plus h. Simply replacing the x in the square root with 16 plus h. F of 16 is 1 over the square root of 16, or 1/4. Note that I didn't really need to calculate f of 16 since that value was already given to me as the y-coordinate of the point 16, 1/4. But I find it never hurts to reinforce the function notation. Plugging in f of 16 plus h and f of 16 into our limit, we end up with the limit as h approaches 0 of 1 over the square root of 16 plus h minus 1/4 all over h. As with any limit, we can start by plugging in the value we're approaching. But if we do that here, we end up with 1 over the square root of 16 plus 0 minus 1/4 over 0, which is 1/4 minus 1/4 over 0, which is 0 over 0, which is indeterminate, signaling that we have more math to do. We'll need to simplify the limit before we can evaluate it. The function f of x equals 1 over the square root of x that we started with was a composition of a rational function, since it's a fraction, and a radical function because of the square root. So we'll have to use a combination of the techniques we used on previous problems involving rational functions and radical functions. Notice that the expression we ended up with in the limit, 1 over the square root of 16 plus h minus 1/4 all over h, has a difference of fractions in the numerator. So just like the previous problems with a rational function, we'll need to start by combining those two fractions into a single fraction. This requires first getting a common denominator. So I'll multiply the top and bottom of the first fraction by 4 and the top and bottom of the second fraction by the square root of 16 plus h. Then combining the two fractions, I get 4 minus the square root of 16 plus h over 4 times the square root of 16 plus h, and that whole fraction is divided by h. I find compound fractions, fractions with fractions within the numerator or denominator, a little hard to look at and would much rather have a simpler looking fraction to work with. To accomplish that here, I can rewrite the division by h as multiplication by 1 over h. The overall result is that the h ends up in the denominator with the 4 times square root of 16 plus h. Notice that even though we've done some simplification, we still cannot just plug in h equals 0 because doing so would still result in the indeterminate form 0 over 0. Instead, after having dealt with the fraction aspect of the problem, we now have to deal with the radical. Again, like our previous problem with the radical function, we can tackle the radical here by multiplying the top and bottom of our new fraction by the conjugate of the numerator. This is an important technique to remember for any time you encounter an expression where either the numerator or denominator has a sum or difference involving a square root. The conjugate of 4 minus the square root of 16 plus h is 4 plus the square root of 16 plus h. Forming the conjugate for a sum or difference involving square roots is always as simple as just changing the operation from plus to minus or from minus to plus. If we multiply the top and bottom by 4 plus the square root of 16 plus h, we get the limit as h approaches 0 of 4 minus the square root of 16 plus h times 4 plus the square root of 16 plus h in the numerator, and 4h square root of 16 plus h times 4 plus square root of 16 plus h in the denominator. Then we need to carefully multiply out the numerator. There's no need to multiply out the denominator because after this step, we'll be able to do some cancellation and plug in h equals 0. If you recognize the form of the factorization in the numerator as that of a difference of squares, a minus b times a plus b equals a squared minus b squared, then simplifying the numerator is a lot easier. You just get 4 squared minus the square root of 16 plus h squared, and you can simplify further from there. That's the true power of multiplying by the conjugate. Because we change the operation from either plus to minus or minus to plus, we always end up with this difference of squares factorization. If you don't recognize the special factorization, that's okay. You can still multiply it out the way you would any pair of binomials. I prefer the FOIL method. First, 4 times 4 is 16. Outer, 4 times the square root of 16 plus h is 4 square root 16 plus h. Inner, 4 times negative square root of 16 plus h is minus 4 square root of 16 plus h. And last, negative square root of 16 plus h times positive square root of 16 plus h is minus the square root of 16 plus h squared. We can cancel the 4 times the square root of 16 plus h terms, leaving just the 16 minus the square root of 16 plus h squared, which is what we got using the difference of squares shortcut. We can simplify just a little bit more by squaring the square root of 16 plus h. The exponent and the square root cancel each other out and leaves 16 minus 16 plus h, which equals 16 minus 16 minus h, which equals negative h. Replacing the numerator in our limit with negative h, we get the limit as h approaches 0 of negative h over 4h times the square root of 16 plus h times 4 plus the square root of 16 plus h. Now we have a factor of h in the numerator and the denominator, which we can cancel out, leaving the limit as h approaches 0 of negative 1 over 4 times the square root of 16 plus h times 4 plus the square root of 16 plus h, and we can finally plug in h equals 0 without getting 0 over 0. If we let h equal 0 now, we get that this limit is equal to negative 1 over 4 times the square root of 16 plus 0 times 4 plus the square root of 16 plus 0, which is negative 1 over 4 times the square root of 16 times 4 plus the square root of 16, or negative 1 over 4 times 4 times 4 plus 4, so negative 1 over 16 times 8, which simplifies to negative 1 over 128. And that is the slope of the tangent line to the function f of x equals 1 over the square root of x at the point 16 1/4, because it is also the derivative of that function evaluated at x equals 16.